Alright guys, welcome back. So in today's episode we're dealing with the very well-known Fibonacci number. So the Fibonacci numbers commonly denoted Fn from a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1s. So for example, f0 is equal to 0, f1 is equal to 1, and then simply fn is equal to fn minus 1 plus fn minus 2. Given n, calculate fn. Okay guys, so this, as exactly like last episode, seems a dynamic programming algorithm. We need to use this approach because what we need to do is to calculate fn minus 2, store it, calculate fn minus 1, store it, and then to calculate fn is just the sum of the two. So we can start by defining, for example, a list which we can call, for example, f. And then since we will, like the input is n and we want to calculate fn, what we can do is to simply define a list composed of n elements, and then we can define f0 is equal to 0 and f1 is equal to 1. Remembering what happened last time, for example, if n is equal to, like, let's say, for example, if n is less or equal than 2, we want to just return n minus 1. You see what I mean? So if n is equal to 1, then that's incorrect though. That's incorrect. Which are the n can be also 0. So if n is equal to 0, then no, I think now we have to multiply by n plus 1. And if n is less or equal than 1, we return n. So for example, if n is equal to 0, we return 0. If n is equal to 1, we return 1. Then of course we initialize the first two numbers of the list. f0 is equal to 0. Actually, it's already initialized here, so it's not necessary. But f1 is equal to 1. And then what we will do is a for loop. So let's say for I in range, we can say 2, and then n. What happens is that I want to change fi. So for example, the first number will be f2, and this is going to be f1 plus f0. Of course, in this case, it's for f2, but what happens in general, I minus 1, and here I minus 2. And we continue again and again, and at the end we return fn minus 1. No, we return fn though. Why? Because we also have f0, so the index here is correct. We started 0, so this will access the nth plus 1 element, which is the one we want to access. So let's, all right guys, it worked first time. Wow, this was unexpected. Okay, so for n equal to 2, the for loop is done just once. We have range 2, 3, and the output is 1, which is 1 plus 0, and this is correct. For n equal to 3, the output is 2. And of course, because this is 1 plus 1, and for n equal to 4, the output is 3. Okay, let's try to submit it to see if it works. And it does work, which is really great, guys. So you see what was the idea of the problem? We just create a list. We create a for loop with which we update this list. And the key is that we don't need to recalculate everything recursively. We can just store the previous numbers and then use them to calculate the next one. Okay. So that was very short, but very useful, for me at least. So thank you very much guys for watching this video, and see you in the next episode.